Imagine a 3,000-year-old lens that might have been part of the world's first telescope, or a cup that changes color thanks to nanotechnology, 1,600 years before we even knew nanoparticles existed. How about a dentist who, 9,000 years ago, drilled teeth with flint, without anesthesia, achieving half-millimeter precision? Today, we explore 6 ancient technologies that science has described but still cannot fully reproduce. And the most astonishing one awaits at the very end. We often look down on the ancient world, viewing them as primitive and ourselves as advanced. We have iPhones, satellites, and AI. They had sticks and stones. It's a convenient narrative, but one that shatters every time something is unearthed that simply shouldn't be there. An artifact that defies our chronology, a technology we can't replicate, not because we lack the will, but because we simply don't understand how they did it. 6 such technologies are before you, each a slap to our modern complacency. Our countdown begins with 6th place. In 7th century BCE, Iraq, in 1850, British archaeologist Austen Henry Layard was excavating the palace of Nimrud, the capital of the Assyrian Empire in modern-day Iraq. Among thousands of artifacts, one unremarkable object stood out, a piece of rock crystal, slightly oval, about 5 centimeters long. Layard placed it in a box with other finds and sent it to the British Museum, where it would remain for over a century, attracting little attention. Imagine a perfectly polished lens made of natural quartz with a focal length of 12 centimeters and a 3-fold magnification. Its surface shows 12 microcavities, remnants of naphtha bubbles trapped within the crystal. This lens was processed on a lapidary wheel, a tool for grinding stones, and dates back to between 750 and 710 BCE, nearly 3,000 years ago. Why would the Assyrians need a lens? The British Museum dryly states it was an object of little practical application. But Italian Assyriology professor Giovanni Pettinato from the University of Rome vehemently disagrees. He points to an astonishing fact. The Assyrians knew that the planet Saturn had a ring. In their reliefs, they depicted it as a god, surrounded by a ring of snakes. It's been proven that Saturn's rings are impossible to see without an optical instrument. If the Nimrud lens were combined with a second similar one, the magnification would increase enough to observe planets. To date, several hundred ancient lenses have been found worldwide, from Egypt's 5th dynasty to Minoan Crete, but none have sparked as much debate as the Nimrud lens. Layard himself suggested that Assyrian artisans used the lens to create microscopic engravings on seals, some so tiny they are only visible under magnification. But this explanation raises a new question. If they had lenses for jewelry work, what prevented them from pointing them skyward? The Nimrud lens lies in a British Museum display case, 3,000 years old, and the debate continues. A trinket, or part of the first telescope in history, 2,300 years before Galileo. 5th place is held by an object that appears to be an ordinary glass cup until you change the lighting. From 1st century CE, Rome, the Lycurgus Cup is the only fully preserved Roman vessel made of dichroic glass. Standing 5 centimeters tall, its walls feature a detailed relief depicting the mythical King Lycurgus entangled in a grapevine, punished by the god Dionysus. The craftsmanship is exquisite, an open work known as a cage cup, where the outer decoration is partially separated from the inner wall. Only a handful of such cups survive, and none compare to this one. Imagine holding the cup. It appears dark green, almost jade-like. Now, place a light source behind it, a candle, a lamp, and the cup transforms, becoming a deep, blood red, ruby red, not pink or orange. Move the light, and it's green again. 2 colors, 1 cup. No paint, no coating. The magic is hidden within the glass itself. In the 1990s, when scientists were finally able to examine the cup's glass under an electron microscope, they saw something unexpected in a 1,600-year-old artifact: nanoparticles. Gold and silver, ground to a size of 50 nanometers, 2,000 times thinner than a human hair, 1,000 times smaller than a grain of salt. These particles were uniformly distributed throughout the glass, refracting light and creating the dichroic effect, nanotechnology in the 1st century CE. We only discovered nanoparticles in the 1970s. The Romans were 16 centuries ahead of us. Researchers at the University of Illinois are attempting to reproduce the Lycurgus Cup's effect using modern methods. They succeed, but not with the same quality or the same precision in particle distribution. A fluke is possible, but Roman glassmaking was an industrial endeavor with thousands of workshops and generations of experience. What if this wasn't an accident, but a lost technology that we are not yet capable of recreating? The cup remains silent, only changing its color. In 4th place are instruments whose sound is so coveted that the world is willing to pay $16 million for them. In Cremona, Italy, between 1,680 and 1,720, Master Antonio Stradivari crafted approximately 1,100 violins, violas, and cellos. Around 650 survive to this day, each an object of reverence. In 2011, the Lady Blunt violin sold for $15.9 million, making it the most expensive musical instrument in history. The scene is this: you hold a Stradivarius violin, and it looks ordinary: wood, varnish, 4 strings. Nothing special at first glance. But when a musician draws a bow across the strings, something happens that cannot be described in words or reproduced. The tone, the depth, the projection of the sound. A Stradivarius fills a concert hall in a way no modern instrument can. Why? Dozens of theories exist. One of the most popular points to the Little Ice Age. Between 1,645 and 1,715, during the Maunder Minimum, temperatures in Europe dropped. Trees grew slower. Their annual rings became denser and closer together, resulting in wood of unique density and elasticity. Stradivari used precisely this wood, spruce and maple, from alpine forests that no longer exist in that form. Another theory suggests chemical treatment. In 2021, scientists from the University of Texas discovered traces of mineral salts, boron, aluminum, sodium, calcium, in the wood of Stradivarius violins, which are absent in untreated wood. Stradivari may have soaked the wood blanks in mineral solutions, impregnating them with something before assembly. In 2023, another team from Taiwan found borax and zinc salts in samples, further supporting the chemical treatment theory. But no one has been able to reproduce the exact composition. Then there's the varnish. It has been analyzed hundreds of times over 3 centuries. Each laboratory offers a different answer, and none align. Some found traces of propolis, others volcanic ash, still others a resin that no longer exists in nature. Stradivari's varnish recipe remains one of the most sought-after formulas in the history of craftsmanship. Dozens of violin makers have attempted to reproduce Stradivari's instruments over the last 3 centuries, copying the shape, selecting wood, imitating the varnish. The result: good violins, sometimes excellent, but not Stradivarius. In 2014, blind tests in Paris showed that most soloists preferred new violins to old ones. However, when the same tests were conducted in 2017 inches, a large concert hall, the old instruments won. Perhaps Stradivarius' secret lies not in the violin itself, but in the space in which it resonates. But this is yet another hypothesis. Antonio Stradivari died in 1737, and his secret departed with him. The bronze medal in our ranking, third place, goes to a discovery that predates the Egyptian pyramids by 4,500 years. Mehrgarh, Balochistan, in modern-day Pakistan, is a Neolithic settlement 9,000 years old, one of the oldest in South Asia. In 2006, an Italo-French research group published results in the journal Times, Nature Times, that sent shockwaves through the dental world. They found 11 molar teeth from 9 adult patients, aged between 7,500 and 9,000 years. Each tooth contained a neat, conical hole, 1 to 3, 5 millimeters in diameter and up to 5 millimeters deep. The walls of the holes were smooth, with concentric rings characteristic of rotational drilling. These were not signs of wear, disease, or ritual. They were evidence of dental intervention. Imagine sitting in a Neolithic village 9,000 years ago with a toothache. A person approaches you with a flint drill, a thin stone rod fixed in a wooden handle, rotated by a bow drill, without anesthesia, without antiseptic. They drill your tooth with half-millimeter precision. Experiments have shown that such a flint drill can penetrate enamel in about a minute. None of the 11 teeth were front teeth. All were molars, meaning the procedure was functional, not decorative. People had their diseased teeth drilled to remove carious tissue. This was 4,500 years before the first Egyptian physician, 6,000 years before Hippocrates, and 8,500 years before the first dental drill. Who taught these people? How did they understand that drilling was necessary? Did they have filling materials, or were the holes left open? Some questions have answers. Traces of beeswax, which could have been used as a filling, were found in some teeth. For the rest, silence. 9,000 years ago, in a village without writing or metal, someone was already a dentist. Official science confirms this, but cannot explain it. Second place, the silver of our ranking, goes to an object that has stood outdoors for 1,600 years and refuses to rust. In New Delhi, India, within the Qutub Minar complex, in the courtyard of the Quwwat-ul-Islam Mosque, stands an iron pillar 21 meters high, with a base diameter of 41 centimeters and weighing approximately 6 metric tons. Inscriptions on the pillar praise Chandragupta Vikramaditya, emperor of the Gupta dynasty, dating it to the early 5th century CE. That's 1,600 years in the open air. Consider this. Delhi is a city with an extreme climate, monsoon rains, humidity, temperatures nearing 50 degrees Celsius, and winter fogs. Any piece of iron in such conditions would rust within months, but not this pillar. For 16 centuries, it has shown only a faint patina, no corrosion, no degradation, no structural damage. In the 16th century, according to accounts, the pillar was shot at with a cannonball, yet it remained unharmed. For 91 years, scientists searched for an answer. From 1912, when British chemists first took samples, until 2003, when a team led by Professor R. Balasubramaniam from the Indian Institute of Technology, Kanpur, published their findings in Times Current Science. The pillar was found to be made of wrought iron with a phosphorus content of about 1%. Modern iron contains less than 5% phosphorus, 20 times less. Ancient metallurgists reduced iron ore with charcoal in a single stage, without a blast furnace, without lime, and without slag separation. Phosphorus remained in the metal. They then hammered the iron repeatedly, forcing the phosphorus from the core to the surface. Within 3 years of its installation, a thin layer of misoite, an amorphous iron oxyhydroxide, formed on the pillar's surface, about half a millimeter thick, 20 microns, 1/5 the thickness of a human hair. This misoite acts as a self-sealing shield, preventing moisture and oxygen from reaching the metal. Modern science can describe this process and explain the chemistry, but it cannot reproduce the ancient forging method. We know how to make stainless steel, but we do it entirely differently, using chromium, nickel, and molybdenum. Ancient Indian blacksmiths achieved the same result with a hammer, charcoal, and phosphorus, without a laboratory, without formulas, without the periodic table. Bala Subramaniam called the pillar a living testament to the skill of ancient Indian metallurgists. 6 metric tons of iron, standing through 16 centuries of monsoon rains, with not a gram of rust. This isn't magic, but it's certainly not a technology we can replicate. Finally, the absolute leader. First place. A stone that served as a GPS for Vikings. In the 10th century North Atlantic, Vikings crossed the ocean from Scandinavia to Iceland, Greenland, and Newfoundland. Thousands of kilometers of open water without a compass. It wouldn't reach Europe from China until the 12th century. Without maps, they didn't exist yet, and without a sextant, invented 700 years later. Icelandic sagas, like the Saga of Raud and the Saga of St. Olaf, mention a mysterious object called a solarstein, or sunstone. When the sky was overcast and the sun invisible, the navigator would take out the stone, hold it up to the sky, and the stone would reveal the sun's position. It sounded like a legend, and for centuries it was treated as such. In 2011, at the bottom of the English Channel, among the wreckage of the English ship Alderney, which sank in 1592, a piece of crystal was found. It was Icelandic spar, a variety of calcite with a unique optical property, double refraction. A ray of light passing through the crystal splits into two. By rotating the crystal while observing 2 images of a single point, one can find the position where both images become equally bright. This position points precisely to the source of polarized light, the sun, even if it's hidden behind clouds. Imagine the scene: a navigator on a longship in the middle of the gray North Sea. The sky is a solid blanket. The horizon merges with the water. No landmarks, no stars, no sun. The navigator pulls a piece of transparent stone the size of a fist from a pouch, raises it to their eyes, and slowly rotates it. At some point, 2 blurry spots within the crystal align. The navigator lowers the stone, turns in the newly found direction, and tells the helmsman which course to maintain. In 2013, physicists from the University of Rennes in France conducted an experiment. They gave Icelandic spar to a group of volunteers and asked them to determine the sun's position on a cloudy day. The result? An accuracy of 1 degree. For comparison, a magnetic compass in high latitudes can have an error of up to 5 degrees due to magnetic declination. The stone proved more accurate than a compass. In 2018, Hungarian physicists built a computer model and showed that navigation using a sunstone would ensure successful voyages from Norway to Greenland in over 90% of cases, even under completely overcast skies. 90% accuracy with a piece of stone. The Vikings didn't know the physics of light polarization, didn't know optics, didn't even know the word calcite. But they knew that if you looked through this particular stone at a gray sky, it would show where the sun was hidden. This knowledge was enough to cross the Atlantic 500 years before Columbus without a single instrument we would call navigational. Just a piece of stone and an understanding of how it worked. An understanding we only fully gained in the 21st century. The Nimrud Lens, the Lycurgus Cup, Stradivarius violins, Mehrgar dental fillings, the Delhi pillar, the Viking Sunstone. 6 technologies, 6 eras, and 1 inconvenient thought. The ancients knew something we don't. Not because they were necessarily smarter, but because they solved problems we don't face. How do you preserve a deceased relative's body if you don't have formalin? How do you cross an ocean if you don't have a compass? How do you make iron that doesn't rust if you don't have chromium? They found answers, and those answers worked. Then the masters died. Empires crumbled. Cities sank, and the answers vanished with them. We live in a world where any knowledge can be Googled in 2 seconds. It seems impossible to lose a technology. It seems that progress is a one-way road, only forward, only upward. Yet, Stradivarius' varnish formula didn't survive, even though he worked only 300 years ago in an era of printing presses and universities. The composition of the Nimrud crystal is known, but the processing method was lost 3,000 years ago. The Missa White on the Delhi pillar is described down to the last molecule, but we cannot replicate the method of the 5th century blacksmiths. The Romans, by accident or design, created nanoparticles and forgot how they did it. The Neolithic dentist from Mehrgar drilled teeth with precision that a modern dentist would envy, and left no record of what they were taught. Perhaps in 1,000 years, someone will look at our iPhone with the same perplexity with which we gaze at the Lycurgus Cup and say, they could do that, and yet they disappeared. Which of these 6 technologies surprised you the most? Share your thoughts below. It's truly fascinating to consider which of these you heard about for the first time. If you learned something new, a like is the best way to let the algorithm know that videos like this are valued. And subscribe to Buried Worlds so you don't miss our next journey into the mysteries that science has described but is yet to unravel. Even stranger things await.